Hi dear students, I hope you all are well. Press the bell icon and subscribe button please to see latest notifications from the channel. Let's start our next work from question number 7 onwards, exercise 6.1 class 12th. The length x of a rectangle is decreasing at the rate of 5 cm per minute. So length of rectangle, let's mark one rectangular shape and we will mark few values on it. Suppose this is a rectangular shape and its length is suppose x centimeter. They have given the length x of rectangle is decreasing. Decreasing means dx over dt because of this time given. So dx over dt decreasing means negative 5 centimeter per minute. And the width y, width is y, is increasing means dy over dt at the rate of 4 centimeter per minute means it is equal to 4 centimeter per minute. So these are the values given. When x is equal to 8 and y equal to 6, find the rates of change of the perimeter. What will be perimeter of rectangle? Suppose it is p, 2 into length plus breadth means 2 into x plus y. So first part is find the rates of change of the perimeter and the area of rectangle. What is the area of rectangle? Length into breadth. So let's start its calculation. Given, what is given to us? X is the length. Given x and y are length and breadth of rectangle respectively. Then what is given? Rate of change of length with respect to time is minus 5 centimeter per minute means it decreases with respect to time at this 5 centimeter per minute, and dy over dt means about breadth it is given, it increases at rate of 4 centimeter per minute. Also we will write let P be the perimeter and A, capital A be the area. So we will write first okay about perimeter and area. So I am writing part number A. What is given? Rate of change of perimeter. So dp over dt. What will be dp over dt? It will be, yes, what is perimeter? Just write okay in first part, sorry. Firstly mention perimeter. Perimeter is 2 into length plus breadth. Now write dp over dt. It will be 2 as it is dx over dt plus dy over dt. Now you have to write values. See, you have dx over dt given here minus 5, and what about dy over dt 4, which will give 2 into minus 1 minus 2. And what about units? And then decide about units. Perimeter in centimeters. We are differentiating with respect to time. So time in minutes given. So minus 2 centimeter per minute. And then we can say what is the meaning of this? Its meaning is, yes, perimeter decreases at the rate of 2 centimeter per minute. So we will give answer of this also. You can mark here. Okay, I am writing. Therefore, perimeter decreases at the rate of 2 centimeter per minute. Here I am ignoring its negative sign because I mentioned it decreases. See next what is given about area. Area, what about area? Area of rectangle. Area of rectangle is, yes, area of rectangle is length into breadth. Now write dA over dt means with respect to time differentiate. Since there are two parts, so we will use product rule. First as it is derivative of second. Then second as it is means y as it is derivative of first means dx over dt. Now we have to find our answer for these values given. You know x is, what is x? 8. And what about dy over dt? It is 4. Then plus y, what is y? Y given 6. And dx over dt minus 5. and in the end don't forget to write units. Since it is area, so centimeter square. With respect to time means per minute. So it will give 32 minus 30 and in the end write centimeter square per minute or 2 centimeter square per minute. So what is the meaning of this? Positive sign is there, therefore area increases at the rate of, yes, it is 2 centimeter square per minute. See next what is given in question number 8. Question number 8 is a balloon which always remains spherical on inflation is being inflated by pumping in 900 cubic centimeters of gas per second. Very first thing, in a sphere we have only one unit, that is radius, and this is given pumping in 900 cubic centimeters of gas per second, means it is about volume, rate of change of volume with respect to time because of second. It is given 900 centimeter cube or cubic centimeters. Then find the rate at which the radius of balloon increases when the radius is 15, means dr over dt you need. Radius r is given 15 centimeter. Let's start our work. Solution of this 8th one. Let r be the radius and v be the volume of spherical balloon. So they are the things given. Now what about dv over dt given? dv over dt, it is 900 centimeter cube per second, or you can mark only s. Now what you need? You have to find rate of change of its radius when radius is 15. So what is radius given? 15 centimeter. Now write, okay, because volume of spherical balloon, what is spherical balloon's volume? V equal to sphere's volume 4 over 3 pi r cube. Now write dv over dt, differentiate with respect to time this value given. So 4 over 3 pi as it is. What about the derivative of this r cube? 3r square into dr over dt. So we have these calculations, 3 cancelled, so you are left with, I'm writing this here, okay. So dv over dt, it is given 900. Forget about units for the time, in that we will mark these. And here you have 4 pi. Pi, you know what is pi? 22 over 7. R square, what is r square? R is 15, so 15 square, and in that dr over dt as it is its value we need. So 900, shift all the values to the left side, 1 over 4 by writing the reciprocals, 7 over 22, 1 over 15 into 15 dr over dt. Now if cancellation possible, then cancel, it will be on 60, 15 into 60, and then 15 into 4, 4 cancelled, and you are left with, yes, you are left with 7 over 22, or dr over dt can be written as, I am writing dr over dt, it is 7 over 22, which can be written as 1 over 22 over 7 or 1 over pi. Now what we are writing, it is in about radius with respect to time. So units of radius centimeter, time is given in seconds. So this is our required answer of question number 8. See next what is given in question number 9. Question number 9 is comparatively more easy. See what is given. A balloon which always remains spherical has a variable radius. So r is the radius of spherical balloon. Find the rate at which its volume is increasing with the radius. So you have to write a rate of change of volume with respect to radius when the letter is 10 centimeter. Letter is 10 centimeter means when the radius is 10 centimeter. Let's start its calculation. Very simple work. Let r be the radius and capital V be the volume of spherical balloon. Now write, okay, given r is 10 centimeter, because volume of spherical balloon is 4 over 3 pi r cube. Now write differentiate differentiation or derivative with respect to radius, because it is given with radius. So dv over dr, it will be 4 over 3 pi as it is, and its derivative 3r square only, and dr over dr means derivative of r with respect to r will give only 1, so I am ignoring that. 3 cancelled. You have 4 pi r square, but r is, yes, r is 10 centimeter given, so I am just writing here, okay, it is, yes, 4 pi into 10 square, so 400 pi. What about volume? Volume always in centimeter cube, and radius in centimeter, so centimeter cube per centimeter. This is our answer of question number 9. See next what is given in question number 10. Question number 10 is, a ladder 5 meter long is leaning against a wall. Suppose this is a wall and a ladder which is leaning against a wall, its length is 5 meter. So its length is 5 meter. No doubt it will touch the ground also. So here I am writing it is ladder. It is touching the ground here. Suppose here this is the distance between foot of wall and foot of ladder, or base of wall and foot of ladder. This is wall, okay, and it is given the bottom of the ladder is pulled along the ground away, means away in this side, at the rate of 2 centimeter per second. 2 centimeter per second given, so it is given in this way. Its rate of change is given 2 centimeter per second. So what is the distance of foot of ladder and base of wall? That is suppose x, and the position of ladder on the wall is here. Suppose its height is y. So we have these things given. See what is calculation here, what is given? It is changing. Foot of ladder is going away from this wall, means dx over dt. With respect to time, it is changing, but it is increasing. That's why it will be positive 2 centimeter per second. Or we can say it is in meters, 0.02 meter per second, because it is in centimeter, 100 centimeter equal to 1 meter, so it will be 0.02 meters per second. So what is given here? So I am writing solution of this. Let x be the distance between foot of ladder and base of wall. Y be the height of, or you can mark y be the height of a ladder on wall, or you can say it is the distance between top of ladder and base of wall. So we have these things given. What about this calculation, this combination? Since wall is vertical, so here you have angle of 90 degree. Read next what is given. How fast is the height on the wall decreasing? Means what do you need? You need dy over dt. You need its value when the foot of ladder is 4 meter away. If its value given 4 meters, then for that you have to find decrease in height of the ladder on the wall. So we have these calculations. You know, if it is combination of these three values and there is a right triangle, we can use only one theorem, that is called Pythagoras theorem. So let's write that calculation. Because wall is vertical, so if wall is vertical, it will be here. Therefore, in right triangle by, you can give it name also if you want, but no need, I think. By, in right triangle by Pythagoras theorem. Only one theorem helps. By Pythagoras theorem. What is Pythagoras theorem? Hypotenuse square equal to base square plus perpendicular square. So we have this calculation. So I am leaving this part. We will do changes here. So our length of ladder was 5 meters. So we have these. What about this? 25 equal to x square plus y square. Now write derivative with respect to t, means d over dt of 25, and here d over dt of x square and d over dt of y square. So we have these values. So now I'm going to change its calculation according to my requirements. See, derivative of a constant value 0, it will be d 2x into dx over dt, here 2y into plus sign here, dy over dt. Now see, you have 2 common, you can leave this 2 for the time and you can mark it as x dx over dt plus y dy over dt equal to 0 over 2, which will give 0 answer. So we have this calculation with us. I am writing it as 1 for the time. Now there are 3 values given here, x, y and 5. So if we have calculation of these things, okay, very first thing I'm writing one here, I will use Pythagoras theorem there. So what about Pythagoras theorem? Here, by using it, you can give it number 1, here you can change it to equation number 2. So from 1 I am writing 1 is 25 equal to x square plus y square, or it can written as y square equal to 25 minus x square, or which can be, I'm changing it now, this can be written as y equal to 25 minus x square, because distance cannot be negative, so I am ignoring negative sign. But if, okay, you can mark if x is equal to 4 meters, what about y then? 25 minus 4 square, or 25 minus 16 square root, or square root of 9, 3 meters. So you will have answer of this equal to 3 meters. So we have, what are the values with us? We can fill x. What about rate of change of this? We have its value dx over dt. We have y with us. What is y? Y's value is 3. You can easily find dy over dt then. So I am going to solve it now by using values. So see what is here. From 2, and equation 2 is x dx over dt plus y dy over dt equal to 0. So here we have x. X is equal to given, see what is x? X is 4 meters. It is given 4 meters, so we can put 4 meters in place of this, and it is with dx over dt. What is dx over dt? 0.02 meter per second. Then you have y is this 3 meters, and dy over dt you need to find equal to 0. Now only calculation work left and we will reach our answer. So it will be 0.08, and here you have meter square per second plus 3 meters dy upon dt equal to 0. Or further, if we continue calculation, we will see 3 meters into dy over dt equal to 0.08 meter square per second. And when you shift 3 meters there, you will get dy upon dt like, okay, as we have, sorry, here you have to write minus sign when you shift there. Before this, okay, it will be negative. So 0.08 meter square per second over 3 meters. So meter one time cancelled. And next we will have calculation by leaving decimal. You will have minus sign before it. It will be 8 over 300 meters per second. We will convert this meter per second, meters into centimeters. 8 into 100, it will be in centimeters per second over 300. We can cancel 0, and you will have in the end 8 over 3 with the negative sign before all these in centimeter per second. So this was our question number 10.